Hello, everyone, and welcome to the sky this month for September 2022. My name's Paul Martinaitis, and this show is brought to you by the Astronomical Society of South Australia. So it's been a great month of observing here in Adelaide. We've had a few clear nights in between the clouds. Saturn has been really well placed in the evenings for observation, so I hope you've had a chance to go and take a look at that. And Saturn will continue to be well observable during September and also, of course, into October. So this month, the action continues with the planets. So we have Neptune coming to opposition on the 17th, and Jupiter, of course, is coming to opposition on the 27th. So it's a wonderful time to be observing planets, and it will continue to be so really through till the end of the year. In terms of the night sky, there's also some nice, as the winter constellations retreat, there's some nice galaxies, spring galaxies coming up in the east, which we'll take a look at shortly. So we'll begin our survey in the sky in the west. So these are the constellations that will be setting first. So this is the region of the sky that you should look at early in your observing session. So, of course, we're in spring. Winter has ended. So some of those traditional winter constellations are now starting to get lower in the sky and will soon be lost below the horizon as the year goes on. So constellations such as Scorpius, Sagittarius, Centaurus, Ophiuchus, they're now starting to get low in the sky, but still quite observable, particularly Scorpius and Sagittarius. And I think during the June and July show, I went through some of the key objects in Sagittarius and Scorpius, respectively. So objects in Sagittarius, such as the Lagoon Nebula, the Trifid, the Omega or Swan Nebula, and the Eagle Nebula, and so on. So if you haven't had a look at some of those objects this year, now's a good chance to take a look before they become too low. So moving now more towards the north, we can see that Hercules is now sunk below the horizon at this time. So we're looking, by the way, on the 20th of September. So that will be sort of later in the month when the sky is dark again, and the time is around 9 p.m. So last month I showed you some of the objects in Lyra, such as the Ring Nebula, which is still visible. You can still take a look at it, even though it's starting to get a little bit low. And the Veil Nebula, which you'll find in Cygnus, that's still also viewable, but this month would be your last chance to do so. So we can see Pegasus is now starting to rise higher in the sky, so that's very distinctive. You can see that big square called the Great Square of Pegasus. Looks huge, particularly when it's near the horizon. So there's a lot of really nice galaxies in Pegasus, which we'll talk about in the coming months as it rises a little bit higher in the sky. Looking now more towards the east, these are the constellations that are now rising and starting to become higher in our sky as spring progresses. You can see there's galaxies galore. Sculptor is now quite well placed, so that's the Sculptor's easel. So there's a lot of really nice galaxies in there, and of course in Fornax as well. So we'll talk about some of the galaxies in Fornax in a future show. But Sculptor is now reasonably well placed for viewing, so I might talk about a few galaxies in that region of the sky. And also, by the way, as you can see that Jupiter and Saturn, so this is 9 p.m. Saturn is now, of course, very high in the sky, near the zenith. Excellent opportunity to be observing Saturn. And even Jupiter is rising, reasonably early now, and it'll get earlier and earlier as the year progresses. So I just wanted to show you a few key galaxies here in Sculptor. The most famous of them would be NGC 253, or the sometimes called the Silver Coin Galaxy, which I'm sure a lot of you would have seen. So to find that, now Sculptor itself is a fairly faint constellation, so from a suburban sky, it's pretty difficult to see, but from a dark sky, you should be able to make out those triangle of stars there. And if you draw a line between the tip of Sculptor there and that bright star there in Cetus, and I've got my Telrad site, you'll find 253 about there. So it's about, I would say, a third of the way kind of along that line. And if you kind of scan across slowly, it's a very big galaxy, and you should see it in your finder scope without too much trouble under a dark sky. So I'll just zoom in a bit, just to show you kind of what it looks like. So you'll know you're seeing the Silver Coin Galaxy. For one, it'll be a really long streak of light. So bearing in mind that this inner circle of the Telrad is actually 1 degree. So you can see it's a very, very large galaxy indeed. Apparent size, I mean. All galaxies are big in an absolute sense. And you'll know that it's 253 as well, because it'll have this triangle of 3 stars sort of right above its core there. So in many eyepieces, it will actually fill up the entire view. If you've got a fairly wide eyepiece, so at least 1 degree in diameter, it'll just fit in. So it'll be a nice long conical halo of light, and under a nice dark sky with a reasonable telescope, say a 8 to 12 inch, you'll also begin to see a lot of the mottling as well, and those dark lanes that you can see here in the photo. It's a truly spectacular galaxy, really, in any telescope. So be sure to give that a go while you're in this region of the sky. So I'll just zoom out a little bit now, and moving over, so I'll just zoom out so we can get some perspective. So we're back at Sculptor, and I'm now going to kind of move this way towards Phoenix, and there's another great galaxy here called NGC 300, and you can see that this one here is very different to 253. So 253 is a very dusty galaxy, and we're actually seeing it sort of edge on. So that concentrates the light and makes it much easier to see. NGC 300 is a classic face-on spiral. So that's why you can see in that picture there, it's got that spiral pattern. But because it's face-on, the light is spread over a much wider area. So its surface brightness is relatively low. So this one here, you need really the best dark sky that you can get to. So through my 12-inch, I can make out a core, and I can see a faint halo, and occasionally I can see a little bit of the mottling. But to see that mottling usually requires a really transparent night, and you need, complete dark adaptation. So I'm just going to zoom out again, and the next galaxy on our little tour is NGC 134. So that's now coming back. So there's 253, 300. We're now moving to NGC 134. I'm just going to zoom in a bit there to show you. So this is another galaxy. Its apparent length is much smaller than NGC 253. It appears more compact, but again, it's sort of somewhat edge on. So it's got a nice concentrated light. So what you'll see here for your eyepiece is quite a bright core, a nucleus, and a nice symmetrical tapered halo. And again, under good conditions, with averted vision, you can sometimes make out some of the mottling in that halo, which correspond to those voids between the spiral arms that you can see there. So that's another nice galaxy to have a look at if you can get to a dark sky. And the final galaxy I wanted to show you just in Sculptor is NGC 55. So we've gone from 300, 134. We're going to zip over to NGC 55 here. This is another wonderful galaxy, probably almost as famous as 253. It's an unusual galaxy. It's an irregular galaxy, as you can kind of see from this picture here. Unfortunately, that's a bit overexposed. But one thing you'll notice again is it's very large in apparent size. So remembering again, that's 1 degree. So it'll pretty much fill up the entire field of view of most eyepieces. And unusually, you can see there the core is actually offset to one side. Most galaxies you see, the core will be in the center or very near it. This is actually offset by quite a bit. So you'll see the core really near one end of this sort of streak of light. And you'll also notice, if you've got good viewing conditions, particularly don't be frightened to try a variety of magnifications. Start with a low magnification, but then crank it up. I would even crank it up to, in my 12-inch, up to 180 or so, maybe even a bit more, to examine this halo in detail. And you should start to see quite a bit of mottling in that halo as well. So you can actually see the mottling that corresponds to all these dark lanes that you can see here in the photo. So these are all really examples of galaxies that are relatively large apparent size, quite bright, and you can also see quite a bit of detail in them. You just need to have dark skies. Good dark adaptation is essential. And you also need to try a variety of magnifications from relatively low, just to get an overall perspective of the galaxy. And then don't be frightened to crank it up and see what other details that higher magnification may bring. Okay, we'll end our our sky tour by looking towards the south. So here's the Southern Cross. Celestial pole is about here, and there's Achernar. So you might remember at the beginning of the year, Achernar was kind of over this side. The Southern Cross was over this side. 6 months later, of course, things have rotated almost 180 degrees. So the Southern Cross and the pointers, they're now heading down towards the horizon. And Achernar is rising higher and higher. So Achernar is the beginning of the great river Eridanus, the second longest constellation in the sky. So that runs all the way from here in the south, all the way through to Orion in the northern sky. So coming up as well later on, you can see here Dorado. A lot of really nice objects and galaxies in Dorado. Still a little bit low at this time, but you can either wait until later in the evening or as the year progresses, that'll begin to rise higher. So we'll talk more about Dorado in an upcoming show later on. You can see there Pavo is very, very well placed for observation. A lot of nice galaxies and objects in Pavo. In particular, the globular cluster 6752, which I've talked about in a previous show. Probably one of the best and brightest globular clusters after 47 Tuc. So you might be very well placed for observation at the moment. And in addition, of course, there's plenty of nice galaxies in Pavo as well. Speaking of 47 Tuc, not a bad time to be viewing that either. And that's just over here in the Small Magellanic Cloud. So most of you would have seen it before. To find it's very easy. All you need to do is find the Small Magellanic Cloud, which you can usually see with the naked eye if you're at a dark sky. And if you look through with binoculars or your finder scope, you'll easily see 47 Tuc as a bright glow or a ball of stars right next to the Small Magellanic Cloud. Okay, let's take a look at the calendar for September. So you can see here the dark sky period shown shaded in blue. So that's where the moon won't be interfering. That begins from about the 17th of the month, sort of a little bit over halfway, and that'll continue right through to the end of September and into early October. So before then, it's a good time to do some lunar observation. Of course, plenty of planetary observation to be done as well, which we'll talk about shortly. Don't want to miss out on that. And you can also look at some double stars as well. And then after the 17th, that's a good time to try and get to a dark site and look at some deep sky objects. So some key events, of course, are the opposition of Neptune on the 17th. And Jupiter is also coming to opposition on the 27th. Although really for both of these planets, the actual day itself is not of great importance. They're good for viewing, of course, for some period of time each side of opposition. So darkness begins at the beginning of the month in September. It began at about 20 past 7 and went through to 5:09 in the morning. By the end of September, the darkness will begin a little bit later at 7:40, and it will go through to 4:35 in the morning. The lunar phases, quarter moon was on the 4th, full moon will be on the 10th, last quarter will be on the 18th, and new moon will be on the 26th. Okay, so this shows you the solar system schematically at the end of August or the beginning of September. So let's start with the inferior planets, Mercury and Venus. So we've had some really good observing windows for both of those planets in the preceding months earlier in the year. September is really not a good time to view either planet. Mercury is moving closer and closer into evening twilight, and Venus is moving closer and closer into morning twilight. So you can see as the month progresses, so we'll wind sort of forward, Mercury has gone into inferior conjunction, so it's in front of the sun, in other words, it appears, and Venus has gone behind the sun into superior conjunction. So, of course, both of them have become unobservable for the moment. So while we're here, let's take a look at Mars. So getting ever closer to Mars, of course, as the year rolls on, we're going to get closer and closer until the opposition there, which will be in December. But for now, we're back here. So as it stands, Mars has an apparent diameter of about 10 minutes of arc. So to give you a comparison, the ball of Saturn at the moment is about 18 minutes of arc. So Mars is a little bit over half the size of the disk of Saturn. So you certainly should be able to resolve the disk in a telescope on a nice steady night. And probably at this stage, you may even, on a really crisp night, it may even be possible to make out some detail. I would certainly try at this stage if I'm taking a look through the telescope. But of course, as the year rolls on, as it gets closer and closer, its size will grow quite rapidly towards its maximum of about, I think, 18 minutes of arc or so in December. So let's now look at some more of the outer planets. So what I'm going to do is just swing the diagram around a bit, and I'm going to wind back to the 17th of September. So while we're here, we can see that Saturn is still very well placed. We're still relatively close on the orbit to Saturn. Its apparent diameter hasn't shrunk much since its opposition, so it's only dimmed a little bit. So still excellent time to be observing Saturn throughout this month and next month as well. Good time to observe Neptune. It reaches opposition on the 17th. So opposition, again, just simply means we are the closest distance to it for this particular orbit, and the sun is directly behind us, so it will both be largest apparent diameter and also brightest at this time of year. So a good month to be observing Neptune, and also through to next month. And then you can see on the 27th, which is about there, you can see we've also reached opposition with Jupiter. And the apparent size of Jupiter at opposition will be about 49.9, or let's say 50 seconds of arc, a massive apparent diameter. In other words, Jupiter will appear to us about 5 times the current diameter of Mars. And Jupiter, again, will be good for observing this month and the next couple of months as well. So now we'll take a look at some of the planetary situations we discussed earlier. So first up is the opposition of Neptune. So this shows you the sky very early on the 17th of September, in fact at 0000 hours, and shows you the general location in the sky where you can find Neptune. So at that time of night, Jupiter, you can see, is relatively high in the sky, and Neptune is actually not too far away. It's kind of between Jupiter and Aquarius. So we'll just zoom in a bit there just to show you where it is. So you can see Jupiter there to the right. There's a star there on the left, Psi Aquarii in Aquarius. It's a 4.2 magnitude star, fairly bright. And you can see that Neptune is kind of a third of the way along, moving away from Psi Aquarii towards Jupiter. It's about a third of the way along. So you could kind of sort of use your TELRAD to move in that direction and probably sweep it up. If you've got a wide field eyepiece in your telescope, you can usually tell when you're looking at Neptune because it'll kind of at first look like a star, but it usually, certainly in an 8-inch or above telescope, has a very deep blue color. And then as you increase magnification, it should start to look like a tiny little blue ball. Other than that, another good way of finding it is to use some sort of app. So Sky Safari is very good, which many of you would be familiar with, which can run on your tablet or a phone. And there are others as well, such as Deep Sky Planner and so forth. But anyway, this gives you just a general idea of where to locate it in the sky. Once you've got the correct field of view, you should really have no trouble seeing it. So when you're having a look at Neptune, this shows you a simulated view through my 12-inch telescope at about 280 times. So when you use enough magnification, if the seeing's steady, you won't unfortunately see any detail on the surface of Neptune, but it will hopefully inflate into a nice tiny little blue marble. Looks really nice through the eyepiece. And while you're at it, take a look for Neptune's moon Triton. So Triton is quite close to Neptune. So you can see in this view here, so it's at greatest elongation, it only gets about 17 seconds of arc away from Neptune. So it's always very close. So at this time, if you take a look at Neptune, don't be fooled by that star there that's some distance away. That star there is about 11.9 magnitudes. And that just happens to be nearby. Triton itself, you can see there, is very, very close to the planet, and it will be quite faint. Its magnitude at the moment is about 13.5. So under a dark sky through a 12-inch, I generally don't have any trouble seeing it, provided that I'm using enough magnification. Sometimes I do need to use a bit of averted vision to sweep it up at first, and then once I know where it is, I can usually see it with direct vision. So while you're at it, of course, while you're taking a look at Neptune, you might as well take a look at Jupiter as well. So this just happens to show you Jupiter, and at that particular time, its moons are in a nice line there. We'll have more to say about Jupiter's moons in a minute. And of course, why not take a look at Saturn as well while you're at it. So we're now going to talk about the star of this month, which is, of course, Jupiter, which is coming to opposition on the 27th. So I'll talk about a few of the features that you can look for on Jupiter, and also some of the events that occur around its moons. So opposition's on the 27th, where it reaches its maximum diameter of 50 seconds of arc and a magnitude of minus 2.9, very, very bright. But like I said, its diameter won't decrease really rapidly after opposition, so it'll still be good for observing from now, October, and also through November as well. So the most prominent feature, which I think most people recognize on Jupiter, is that the eye of Jupiter, or the so-called Great Red Spot, or GRS. It's an amazing feature, really. It's really just a vortex or a storm, but it's lasted at least 400 years. So it's been over 400 years since it was first observed. So we know it's been around for at least that long, but of course it's probably been around for hundreds of years before that as well. It's hard to say. Certainly it's changed its appearances from time to time. Sometimes it gets a deeper red, sometimes it gets very light, sometimes it's almost disappeared, and it moves around the planet's surface quite a bit as well. So it's really amazing. So the Great Red Spot, of course, is something always to look for, and I'll show you how to determine whether that'll be visible on a particular night. Of course, through any size telescope, you'll see a series of horizontal bands moving across the disk as well. If you've got a larger telescope and you've got very good seeing, within those bands, you'll start to see some of the other features that you can see there in that photograph, which I took from Stockport during the 2018 opposition. So you'll start to see some of those white little spots that you can see there in the polar regions on the top and the bottom of the disk. And you can also sometimes, if you're really fortunate and you've got good seeing, you can get glimpses of all those swirls that you can see in the belt, sometimes called festoons. So all those swirly little bits that you can see next to the great red spot and the greyish band above it as well. So the main thing I recommend is try and choose a night of good seeing. If you have a telescope such as a Newtonian with a mirror, try and make sure it's cooled down as much as possible, preferably for a couple of hours before you observe, and also try and observe when Jupiter's nice and high in the sky. And if all those things come together, the seeing's good. You can get some glimpses of some amazing detail through the eyepiece. You can see most of the detail that you can see there in that picture. So Jupiter has quite a few events associated with it. We have the Great Red Spot, which we've just talked about. So Jupiter rotates. A Jupiter day is 10 hours, much quicker than the Earth. So whether or not the Great Red Spot is visible just simply depends on what part of the rotation of Jupiter is facing us. And you've also got the 4 Galilean moons as well, and they of course form their own little solar system. So in addition to just forming different patterns and configurations, they also have some interesting events associated with them. One of the most interesting, I think, is what's called a shadow transit. So here's an example of a shadow transit of Io. So you can see Io, the innermost moon there to the right, that bright spot, and you can see that it's actually casting a shadow on the surface of the planet. So that's called a shadow transit. And you can observe that in a reasonable telescope. It's one of my favorite objects to observe. So you can actually see that shadow travel across the disk of Jupiter. And there's also eclipses as well, where the Jupiter itself will actually eclipse one of its moons and make it disappear or reappear. So there's many of these events occurring throughout the month. And I thought, rather than just giving you a few specific dates, which could very well be clouded out or may not be convenient for you to view, what I've done is I've actually provided you with a file which contains a whole list of these events, which will be visible from Adelaide, and they're in Adelaide time. So I'll take you through that file just to show you what information's in it. So this is the information file that you'll be able to access via a link in this video's description. So this provides predictions for September for visibility of the Great Red Spot, shadow transits, and also eclipses by Jupiter's moons. So let's take a look at the GRS transit first. So let's just scroll down. Well, let's have a look at this one here, for example. So for a GRS transit, there's 3 times listed. First visible means when it's just rotating into view. Mid-transit is when it's pretty much bang on in the middle of Jupiter's disk. And last visible, of course, is when it's just about to rotate out of view. So generally, mid-transit, or half an hour each side of mid-transit, that's where you want to be trying to observe it. And that also gives you, an impression of really how fast Jupiter's rotating, because, at around 7 o'clock, it first comes into view. By 10 o'clock, that's only 3 hours later, it's swept right across and it's about to go out of view again. So really gives you that impression of how fast Jupiter's rotating. Now, the other important piece of information for all of these events is altitude. So that is the altitude of Jupiter at that particular time. So if it's -12, that means it's below the horizon. So you wouldn't be able to see the beginning of the transit, of this GRS transit. Mid-transit would only be 7 degrees, and Jupiter will only be 25 degrees above the horizon when it ends. So this one here is really not a good one to look at. So I'll just move through and just show you one that is more reasonable. There was one here. Yeah, here we go. On the 9th of September at 11:50. So you can see here, starts at 48 degrees, mid-transit. Jupiter's right up at 54 degrees, pretty much as high as it gets. The only disadvantage, of course, is mid-transit at the moment. For this one is, 1:20 in the morning. But it'll be nice and high, so you should be able to get a really great view of the planet if it's clear. So I'll just show you this in stellarium. So this is the 10th of September at 1:23. So here we are, 10th of September. Time is about 1:22, 1:23. And if we zoom in on Jupiter's disk, you can see there the great red spot is pretty much bang on in the middle of the disk. Okay, so the other type of event that's very interesting to observe is a shadow transit, like I showed you in that picture before. So all of the Galilean moons perform shadow transits. Io is probably the most common one, I guess, because it probably has the quickest orbital period, being the innermost moon. So some events are better than others. So always pay attention to that altitude. So sometimes, for example, these ones down, let's say here, starts off below the horizon, and you can only see the egress at 8 degrees. So I wouldn't even bother with that. But this one here on the 20th of September at 23:34, that has an altitude of 52 degrees. So nice and high. So there's 3 times listed. Mid shadow is when the shadow is pretty much right in the middle of Jupiter's disk. Ingress, that's when it's just about to touch and enter the disk. Egress is when the shadow is about to leave the disk. So I'll just show you this example in stellarium. So I've set the time for the 20th of September, and the time will be 22:27. So the time, 20th of September, the time here is shown as 22:21. So you can see there's Io moving quite close to the disk of Jupiter. And then I'll just advance time 1 minute at a time. And you can just see there, the shadow is just entering the disk of Jupiter. And then you can see as time goes on, the shadow will pass across. So here, that would be the time listed as mid-transit, so roughly 11:30. And by the way, when you see the shadow transit, you'll generally quite easily see the shadow. But if you look carefully, you should also see the moon. But it's a bit hard to see because, of course, Jupiter itself is very bright, and you've got a bright moon, so you don't have a lot of contrast. But sometimes the moon will appear as just a bright spot behind the shadow transit. So we'll just advance time again. So that'll move across. And then by the time the shadow reaches the other side of the disk, that would be the shadow egress, where the shadow just leaves the edge of the disk. And then finally the moon will be back in with space behind it as well. So the last type of event I want to show you about is an eclipse of one of the moons. And in some ways, they're the most spectacular type of events, particularly when the moons are disappearing, which happened before opposition. So there's a number of examples. So a particularly good one is this one that is occurring on the 25th of September. The 24th of September at 11:30. So for an eclipse, there's generally 2 times listed. So this says Ganymede eclipsed by Jupiter disappears. So you want to begin observing maybe 20 minutes, half an hour before that time, just to make sure you don't miss it. And the disappearance time is the time when Ganymede, in this case, will move into Jupiter's shadow, and it will just gradually get dimmer and dimmer and dimmer, and then suddenly disappear as it moves into shadow. So it'll actually occur before it actually hits the disk. So it's not an actual occultation. The occultation then occurs sometime later. So that's when the planet actually moves behind Jupiter. And then the other event associated with that will be this one here. where it says occulted by Jupiter, egress. So that means the planet has travelled behind Jupiter. Egress, occultation egress, is when it appears on the other side. So I'll show you that event in Stellarium. So disappearance time is 24th of September at 23:29. So this shows you the situation on the 24th of September. So we're about 11:15. I'll just zoom in so we can really see what's happening. So you can see Ganymede is now quite close to Jupiter, but it hasn't yet passed behind it. And I'll just advance time. And you can see there that it hasn't actually hit the disk of Jupiter, but as we approach the disappearance time, within a couple of minutes, it's just going to dim, and then suddenly it's just going to disappear. So it's really spectacular watching that through the eyepiece. So it's actually still there. We just can't see it because the sun's over here to the right somewhere, and Jupiter's shadow is now blocking it. And then, of course, it'll move behind Jupiter. And what I'm going to do is now just fast forward to the egress time, which was about 2:30. So I'll just go a bit before that. So there's 2:25. You can see there 2:26. And as we approach 2:30, you can see it's popped out the other side again. So eclipses, I think, are one of the most spectacular things to watch, particularly when that moon disappears like that. So hopefully you'll find that list of times useful, those list of events. You'll be able to pick a time that's suitable, hopefully weather-wise, and suits when you're out at the telescope. Just pay attention to that altitude to make sure that the event is a reasonable height for you. Well, thanks everyone for joining me in today's show. I really appreciate it. It probably went on a bit longer than I would normally like, but we had a lot of things to go through, particularly with Jupiter. So I hope you find the information interesting, particularly that file. So again, I'll put a link to that events file in the description for this video, and I'll also post that file to the ASSA forum for ASSA members to access as well. And by the way, just while I'm here, Stellarium, of course, that's the software I use to show you all those simulated views. That's freely available. It's really excellent software, and I highly recommend that you try it. So it's available, as you can see, on Linux, Mac OS, and also Windows. And I think you can also use a web version as well. So that's at stellarium.org. So what you might like to do is download Stellarium. And then what you can do is type in some of the times you see on that file, just to confirm the times, and you can actually get a simulated view of what you can expect Jupiter to look like. So good luck with the weather. I hope you get some great observing opportunities this month, and I look forward to seeing you in October. Bye for now.